Biography was published by International Biographic Center, Great Britain, as 200,000 outstanding scientists. She has published more than 50 research papers in reputed journal. Now I am requesting to you, ma'am, please share your expertise with us.
Thank you, Gangsha. Thank you so much. Let me start. Are you able to see my presentation?
Yes, ma'am.
It's in full screen mode.
Yes, ma'am.
Okay, can you see the change also?
Yes, ma'am.
Right. Thank you so much, Akanksha. So the topic of my presentation is future research opportunities in the field of optical communication and IoT. So I'll give you a quick review of optical communication because in the last day, yesterday, we also discussed some part of the optical network. So I'll just keep it very brief. So in the optical communication, we are converting any type of data, any electrical data, any audio, any video data into the digital form. And then we are transmitting the information in the form of light. Whenever we need to transmit 1 or 0, correspondingly, we are transmitting light or no light. So this is the way how the optical communication takes place. So here you can see these blue lines are our optical fiber, and we are transmitting the signal in the form of light. Then we are using some amplifiers and some other devices in between, some couplers. Then we are using some amplifiers at some distance. And normally earlier we were using the electrical amplifier, in which we are converting the light signal to back to the electrical signal. And then we are again converting amplified and again converting that signal to the optical signal. But nowadays we are not using those type of amplifier. We are using EDF amplifier, Ytterium amplifier. These type of amplifiers are direct optical amplifiers which can amplify the light directly. So there is no need to convert any optical signal to the electrical signal just for amplification. So this is a very good topic of the research. Like many researchers are working in the EDF amplifier, and normally nowadays we can see that there is not delay in the voice signal. If somebody is talking from US to Delhi, and then we are seeing that there is not much delay. This is all because we are having direct amplifier. Earlier, around 10-12 years back, there was some delay, but due to these EDFs, now the delay is minimum. And then we are having the receiver, which again convert the light signal to the optical signal. This is just a general brief introduction about the optical communication system. So if we are talking about the transmission bands which are given by the government, so I would like to say that it's not like we can use any wavelength for transmission. There are some organizations who are standardizing the bands and who are looking at the advancements in the technology. So if we are talking about the transmission, it's in the form of light, and who is creating the light? Are lasers are the basic source of light. So all the physics people who are working on the lasers, they are developing lasers for the different wavelengths. And all the community who are working on the optical fiber, they are trying to take that laser source through the optical fiber. But we just want that the optical fiber should carry the information in a smooth way. Means there should not be distortion. So if we are talking about the distortion perspective, we cannot say that we are dependent upon the fiber characteristics. So for that matter, optical communication have identified some windows that only through these windows we can transmit the signal, because in these windows the optical fiber is giving us less attenuation as compared to the other wavelength. So earlier the first window was 850, which was a very initial window. But if we are comparing it with the second, third and fourth window, it is showing the highest attenuation. And we are not using it for long reach applications. We are using it just for short reach application. The second is 1310 window. It's a good window and it is giving zero dispersion for single mode fiber, but it is having little high attenuation as compared to the third window. So, but we are using this window nowadays for practical purpose, and it is used mainly for medium reach applications. It means if we want to set up some system, say 10 kilometers, then we can use this window. Means we can transmit the signal at this 1310 lasers. And the other one is the third window is 1550, which is the third window. So this is a C band, and the range for this band is basically 1525 nanometer to 1565. So means laser is generating the light in this range, and we can transmit our information on these particular ranges for that laser. So it is having the lowest attenuation, and normally in all over India, all over world, we are using this third window, that is 1550. And it is used for almost all long reach application. And the best part is that in this window, we are also using one very important technique, DWDM, which is known as a dense wavelength division multiplexing technique. So it means nowadays, if we are talking about practical purpose, 1550 nanometer is the ideal window. And the last one is fourth window, which is the L band. This is a newest window, which scientists just discovered. And the range is 1570 nanometer to 1610 nanometer. So if you want to do some research in the field of optical communication, then you can see that you can develop some system for third window or fourth window if you want to generate some long reach or long distance communication. This is the basic structure of the optical fiber. See, if you will see the optical fiber, it's just like a hair type of structure. Means the size is even less than the hair. So just imagine that a fiber which is just the size of which is just less than hair can carry around 5 lakh of users data simultaneously. So it means it is having very, very high speed. And it's not very, very old technology. It's a very new technology. The main problem is that optical fiber is made up of glass, and glass is very brittle. It can be break down. So to give the strength to that fiber, bare fiber, the basic silica fiber, the glass fiber, we are putting some jackets, like the coating is there, the tight buffer is there, strength membrane is there, cable jacket is there. So because to make this fiber very, very safe, and to make this fiber little means we have to bend the fiber. So to provide the strength to these fibers, we have to provide some jackets of the fiber. And companies are doing research for the materials which can provide the strength to these bare fibers. So this is a basic architecture of the optical fiber. But when we have to lay down the optical fiber, it's not like one company is laying down the one optical fiber. We are having bundles of optical fiber. In the second figure, you can see that when company need to install the fibers, they are basically making these fiber, packing these fiber in bundles, and then they can basically transmit their data. So in the third diagram, you can see that the people are basically trying to install the optical fiber. So the main issue I told you that this we have because the fiber is breakable. Bare fiber is breakable, not the with jackets. Bare fiber is breakable, and there might be some bending losses. So we don't want that those bending losses should be there. So we have to keep certain diameter of this fiber, that it should we cannot bend it like very, very narrow. So the people are basically putting these fiber, digging and laying down these fibers. So in this diagram, you can see that. So these are some example of packaging of fibers, like 2 fibers can be packed in one main roll. And here you can see the different structures or the fibers can be packed. So it depends upon the companies. The main point is that there are certain organizations worldwide who are providing the standards that this should be the size of the core, this should be the size of the cladding, because we have to match each and everything. Okay, so there are some organizations who are controlling these mechanisms. And here in this case, you can also see this fiber, which this is known as a hollow fiber. This was another type of fiber, which is hollow fiber, which is hollow from inside, but it is not all used for very long communication. Normally for long distance communication, we are using single mode fiber. And optical fiber is not only used for communication. You can see that optical communication can be used for decorative material purposes. And nowadays the major research is going on for multi-core fiber. Multi-core fiber is means, normally I told you that in this slide we are having one core and one cladding. Here is one core and there is one cladding. So multi-core means that in one cladding we can have multiple cores here. So this is the latest research which is going on, which is known as the MCF fiber, multi-core fiber. Till now, there is this is on the research phase, and there is not any practical fiber which has been laid down. But this is the newest research that people are working upon designing of multi-core fiber, because it can carry a huge amount of data. You can say that in one core, one stream of data can be transmitted. In the second core, the second stream of, if you are putting, if you can means merge 4 cores in one cladding, so you can say that the capacity of this optical fiber becomes 4 folds, 4 times, because we can adjust 4 core in one cladding. So but what I mean to say that this is the latest research on which people are working for designing these type of fibers. So if we are talking about the bit rate, what is the maximum capacity till now we have achieved? So Nokia Bell Labs announced that its researcher broke the previous record, means and set a new one of the highest single carrier bit rate of 1.52 terabits per second. So you can imagine this, there is a huge speed, 1.52 terabits per in 1 second we can transmit this much of information. But the point is, there are 2 main hurdles when we are looking for the practical applicability of these points. Number 1, my laser should be smart enough, the speed of my laser should be such that it can support this much of data. Then my fiber should be able to carry this much of data. And third is, my photodetectors should also be able to catch this much of data. So, but till now we have designed some component, Nokia Bell Labs, and in which they can say they are saying that they can get this 1.52 terabits per second. And they have managed it to do on a distance of 80 kilometers. They have used a standard single mode fiber. I told you that for long distance applications, we are normally using single mode fiber. So this is a fastest data transfer on the current state of art technology is approximately 400 gigabits per second. So this is the highest capacity of the optical fiber, which has been done by the Nokia. So if we are talking about the Indian perspective, so you will be amazed to know that India is in a very good position for the optical fiber. We are having a very good number of companies who are manufacturing optical fiber. We are having even very good number of companies who are designing the laser. So if we are talking about the optical perspective, India is in a very good position because the manufacturing units of each and every component is still in India. So these are some very good optical fiber companies who are generating different type of optical cables. And if we are talking about the global perspective, so globally, many companies are there. Comm is there in the US, and they are having very good infrastructure. Corning is there. So these are the list of some top fiber manufacturing companies who are working to design the different type of optical fiber. So if we are talking about the government initiative, government of India, so Indian government is know that the internet connectivity is required. So they have started one project. It is 5 years project, which is known as the Bharatnet Scheme. They just initiated this project to basically connect all the rural areas, and through this project around 2.5 lakh gram panchayats and 6 lakh villages of the country, they were covered. And this scheme was under this 2021. This project was there, in which there was need to connect all these rural areas. So it means optical fiber is not only in the urban cities, it is now in all the rural area also. So while designing and while doing research, the major point is that optical network architecture. So what is the need of this optical network architecture, and what is the funda behind that? See, if we just think about the optical network design. So the point is that for which point we have to design the network. When I have to start any research in this area, I need to understand that this network should be for which type of application. Suppose I just want to connect the major cities like Delhi with Bombay with Ahmedabad. If I just want to connect the major cities, so then there is a different type of architecture. If suppose I want to design a network like for from Delhi to NCR region to Noida to Faridabad, or I can say multiple sectors of Noida, then the network requirements are different. And if we are talking about the network which is coming at my home, if we are talking about in one sector, there are multiple societies and we have to connect those societies. So the network requirement are different. So depending upon the different type of network requirement, we can categorize the network in three types. The first one is long haul network. Long haul networks are those network like if we want to connect Delhi to Bombay, long distance application. When we are talking about long haul network, we cannot afford that there should be any delay. We cannot afford that fiber is cut and our data has been stuck. So if we are talking about these angles and these type of networks, and then we have to think about the other routes. We have to think about that there should not be any delay. If there is a cut in the first fiber, we have to install multiple fibers, multiple routes should be there. So the requirement is totally different. So metro network is, you can imagine, like I told you, the city network, and PON access network is basically PON network, in which we are saying that when end user is accessing the information, then it is known as an access network. So if you are talking about the next generation network, so all the next generation networks are backed with the optical communication. So optical communication, if you think about any latest technology, if you think about big data transmission is required by the optical communication. If you think about IoT applications, in IoT, the transmission should be through the optical communication. Even if we are talking about the wireless sensor network, wireless is giving us the flexibility that we can, means we can roam around. But if we are talking about the speed, then optical communication is the only media which is giving such a huge speed. So all the wireless centers, like all the base stations, if we are talking about the interconnectivity, the backbone structure of every communication is through the optical communication, is by the optical communication. So in this diagram, you can see our 5G mobile phone, the connectivity of the IoT. So there are multiple applications like the cloud computing is there. If we want to transfer video, if we are talking about the robotic arms, so there are multiple applications in which the communication is through the optical communication. So in the first diagram, you can see the inner network, the core network, which is DWDM mesh ring network, is basically the long haul network. And after that, the second layer is in which you can see a ring with black buildings. These are ADM add-drop multiplexer. This is basically the metro network. And the last network, which is basically when we are accessing the information, is known as the access network. So optical communication is providing a high speed, low latency, and most reliable communication if we are talking for the today's scenario. So I just discussed that we are using one very important term, which is known as a DWDM. It's not a very new term. And since in India, we are using this DWDM and WDM from 2000 only. So what is that? So suppose we are transmitting one stream of data, like 5 Gbps over the same fiber, and we are using one laser for transmitting that data. So in the case of optical communication, we can transmit multiple laser beams over the same fiber. So it means if lambda 1 is my first stream of 5 Gbps, and we are transmitting this lambda 1 at suppose 5 at 1550 nanometer, the lambda 2 could be at 1560 nanometer, another stream of data. And means if I can manage to have 4 lasers, then I can transmit 5 into 4, 20 Gbps of data over the same fiber. And the main property of the fiber is that the fiber can carry all these lasers independently. So they are not merging the data. Okay, there are some issues, but there are certain techniques to tackle them. So this is the main part, that through the optical communication we can carry multiple streams of the different wavelengths. So on the right hand side you can see that over the same fiber we can take 7, 8 wavelengths we can transmit over the same fiber. So now that another technique is known as a DWDM, which is known as a dense. Dense means when in the wavelength division multiplexing, we are densely packing the wavelengths, right? Here we are seeing WDM is normally the technique and DWDM is densely packing. Now, how dense we can pack, how densely we can pack the wavelengths. So if we are talking about the standards, so the government has given that the difference between these two wavelengths should be 0.8 nanometer, right? So 0.8 nanometer means first wavelength suppose at 1550 and the second wavelength at 1550.8. So you can imagine if we are packing all these wavelengths in a very dense manner, so means the capacity of that optical fiber has been increased, means over the same fiber you can say that if we can pack 40 wavelengths in that, so my capacity of the optical fiber has been increased 40 times. Okay, so nowadays we are not using any single WDM type of technique. We are using merging technique, like we are using time division multiplexing first, and then we are transmitting the signal over some wavelengths, means over densely packing DWDM technique. So it means by using this DWDM technique, we can increase the capacity. So this is a scenario of SONET Delhi and suppose this SONET Bombay. So you can see from long haul network, we are taking the data, then add drop multiplexers are there. What is the function of these add drop multiplexers? They will add some traffic and they will retrieve some traffic. Like if you want to talk somebody at the Bombay, and then you are saying something, when you are saying something, you have to upload the information. And if when you are listening something, you have to download that information. So just imagine when we are talking with the person who is at Bombay and we are continuously talking with them. So the system is giving very, very less delay. So every time we are saying something, we are sending our data through these ADMs. So this is the SONET in metro network. So this is another structure, like we are having some core routers, we are having add-drop multiplexers from the long haul DWDM network. Basically, when we are designing the network, the normal structure which we are using is the ring architecture. So there are star networks, we know about the bus network, there are different topologies, but normally for the main core topology, we are using the ring architecture. So even in the metro network, we are using certain rings to transfer the data from one location to the another location. So then this was all about the metro network and the long haul network. The last network, which is known as the access network. Now we will discuss about that. See, in the fiber, when we are talking about the access network, normally you have heard about the term fiber to the X, FTTX, and X could be curb, X could be building B. So it means fiber to the X when we are taking the fiber near to the home, when we are accessing the information. Those type of networks are known as the access network. Okay, so but when we are talking about our devices at our home, if we're talking about the television at our home, if we're talking about the other devices, so these devices are just till now we are having these devices which are electrically operated. We are providing the electrical signal to them. We are not directly giving the optical signal to them. Till a router, we can say that fiber line is there, but after that when we are using some Wi-Fi, we are giving the wireless flexibility, but till the point we can get the information from the fiber, that decides that which type of network is it, like fiber to the curb network. Here you can see that from the core network we are using one feeder fiber, and from this feeder fiber we are giving the access to the different houses through the copper cable. Okay, so this is the first type of network. This is known as a fiber to the curb network. So if you were looking for the transceivers at this point, so it needs only two transceivers, one at this point and second at this point. The other solution could be, but here the problem is that we are basically taking the data from the electrical signal. The purple lines are basically electrical wires. So when we are talking about the electrical wires, they cannot carry that much of data as the optical fiber can take it. So the solution to that is that we are taking the fibers to each and every home, and we are using some transceivers. Transceivers are basically used to convert the data from like optical signal to the electrical signal. So this is a second solution. But if you will look at this solution, which is known as a fiber to the premises, if you are looking at at this solution, then the cost is high, because for each and every host we are using some separate fiber. So this is another solution. So what is the how we can solve this problem? In the third way, what we did, that we have used one single cable to carry the data to the premises, and then from that we are using some short length lasers to connect the different houses. So this is the other solution. So the obvious solution which is there is known as a PON solution, passive optical network. So when you will discuss about this network, PON word is very, very common. So EPON, GPON, there are means number of network which are there. And in the yesterday's lecture, Dr. Shilpa have discussed about those networks. So I am not going to discuss all those. So here passive optical network means like here you can see we are using some splitters. So they'll split the information in through two fibers, and then again we are using a splitter. So with the help of splitters, we can basically try to send the signal from one point to the another. So this is another solution which is known as a PON solution. So these are some network architecture. So if we are looking for the overall network, how optical communication comes to our life, you can see that in every sector, if we are talking about the connectivity for the core network, for the cloud data centers, for the SANs, for the broadcast network, access network. So you can see the optical backbone structure is there everywhere if you're talking about any application which require communication. So optical networks become the integral part of the tomorrow's technology. So this is the optical fiber network in India. If you will see the network in India, so here you can see it's the basic network for the optical fibers has been laid down. And in the second diagram, this is basically the DWDM network, which is basically the rings are there. Certain rings has been there. So this is the basically DWDM network. Dr. Shilpa already discussed about this architecture, this diagram about the railnet. So I'm not going to discuss that. So if I'm talking about the research trends in the field of optical communication, so here you can see that nowadays we are talking about the cloud computing. There are certain clouds, central cloud is there, some edge cloud is there, some access cloud is there. And cloud computing means what? That the cloud server is placed at somewhere, suppose at US, and you want to use the services of that cloud. So every time if you are using the cloud which is there at suppose US, so when you are putting some data, uploading some data, downloading some data, so it means every time when you are connecting with the cloud, you are using the optical services. So if the cloud is very, very near to your house, then you are using just access WDM. But if it is beyond the metro, then you are using metro WDM. But if it is beyond the country or some very, very long, then we are using core WDM. So it means if we are talking about the optical communication role for all the latest technology like 4G, 5G and upcoming technology, cloud computing. So this is a very good backbone structure. So what is the role of the optics in 5G networks? So if in this diagram, you can see that all the big data centers, if we're talking about the data centers, Yahoo, YouTube, Google, so all these data centers are connected through the optical fiber, right? Even all the global interconnectivity, when we are talking about the connectivity with the different countries, that is through the optical communication. If we are talking about the central offices, even our universities, even our labs, even our buildings, everything is connected with the optical communication. Like if you are talking about these small cells, even which are placed on buildings or poles, so even these are connected with the fiber. So there are certain areas in which people are working, like radio over fiber is an emerging area. Then other area is like we are using relaying system for communication. So you can see that there is a optical fiber plays an important role in the upcoming 5G network. Now this is uh, uh, this is another area in which people are working. Nowadays, we are talking about the software defined networking. Okay, in the wireless communication, we know that in the when we are talking about as software defined networking, we are making the system more intelligent. We are making the system means that the system can take the decision at its own based upon the algorithms. Similar is the case with the optical communication. Nowadays, people are working upon software defined flexible transmission. Means my system should be smart enough. We are trying to make the systems in such a way that my system should be smart enough that it should decide its own route. Like suppose if the channel conditions are good, so then it should decide at its own that I can use the minimum type of modulation technique or minimum power through which we can transmit the information. And if the channel conditions are not good, then we have to use the other route, or we have to use the other parameters. Highest power can be increased. So means the system should be smart enough to take the decision at its own. So these are some flexible communication on which people are working. So you can see that they are that through these algorithms we can connect with the different type of EPON, GPON. So
No, मम्मा काम कर रही है.
so so if somebody wants to do research in this area, research issues in the optical network, if somebody wants to do research in this area, then he or she can work for the systems which can support flexible and dynamic system, and they can work on the algorithms which can provide the millisecond delay. Okay, and plus they can develop some algorithm which can support higher capacity, higher data rate, and we can provide design the system which can have massive device connectivity. Okay, so people are working on designing the smart algorithms for the software defined radio networking, and some we can also develop some algorithms which can control the network traffic. And the main point is which is a very important area nowadays, is basically the green communication. If you are working in either in wireless communication or in optical communication or in IoT, green is the latest area. Means we have to design something which should be energy efficient, plus we can design something which should be biodegradable. So if you are providing designing something which can save the energy, then this is a current very good research area on which people are working. So if you are developing some algorithm and they can save the energy, so that is again an invention. The another area which is very important is the free space optics. So till now I just discussed that optical communication happens through the fiber, but it's not like that. Optical communication is also a wireless communication. We can, if we are not using any fiber, and if you can see here in this diagram that on this building 1 we are using one laser. This laser will transmit its beam, and on the building 2 there is one photo detector which catches the information. So this is another area on which people are working. So what is the advantage over here is that there is the cost of the setup is very low, because there is no need to dig and install the fibers. So because here in this case we have to just only install the laser and the photo detector. So but there are certain drawbacks also. If there is fog, then my transmission beam then the beam from this lasers cannot be transmitted properly to this photo detector. So laser could be there if rain is there, if smog is there. So we have to means we can do research to solve these problems, right? So but if we are talking about the applications, there are huge applications of this FSO link, and today there is a huge business in this area, fiber free space optics. If we are looking the applications and which area this FSO can work, there are huge application in outdoor V2X transportation. So all these can be connected through this FSO. We just need to set up the lasers and transmitters. If we're talking about the industrial operations, if we're talking about the inter-building connections, so you can see that these buildings are connected with each other through the lasers. And if we're talking about the smart healthcare system, smart grid communication, even our airports are connected with the FSO links. Okay, even FSO link is not used only at this uh, Earth. We can also use this FSO link undersea. All the submarines, cables, all these are connected with the FSO link. And if we're talking about the space communication, satellite with airplanes, and so it is all through the FSO applications. So that you can see the connectivity of some towers with the building. So if we are talking about a different application, FSO is basically a very important area, because here the cost is very minimum. Setup cost is very minimum, and we can easily install it. So in all the military applications, we can set up all these FSO link for the transmission of the information. The plus second point, important point is that through these FSO link, because we are transmitting the information from the lasers, and laser can carry a huge amount of data. So that's why we can say that it can carry a huge amount of data as compared to the other media. But the major issue in the FSO is that it is a line of sight communication. This is a major issue. So here you can see that optical wireless communication in 5G and IoT platforms. So you can see that how it happens in smart homes. Optical communication is there. Nowadays we are talking about light communication. Okay? So we are transmitting the signal in the form of light. So this is again our e-health, smart shopping, space communication, cellular, underwater. I told you that there is a huge huge number of applications in which this FSO is working. So if we are if you want to work in this area, in this free space optics, then there are certain problems and challenges on which we can work upon. The first is that when we are talking about the FSO communication, the main point is that we require a higher power for the laser. But if we are talking about the side effect of these higher power, if the bird is coming and he just touch the laser beam, then he can vibrate. The bird can vibrate. Means this is we have to limit the power also. It's not like that we can transmit n number of power from the lasers. So government have given some standards for these power levels, and we just want to design the systems which should be power efficient. Means they can transmit the information of over a large distance, and they require less power. The second point is when we are talking about the high-speed FSO system, we require high-speed modulation. So you can work upon these modulation schemes. We can work upon the security angles. We can work upon the coding schemes. So the next is that the overall system design should use low power consumption, which I already told you. Plus, we can also work upon the problems like rain, problems like smog. So how my signal can be transmitted through these attenuation when there are such type of attenuations, right? And the major problem in the case of FSO is tracking endpoint. If there is some shift in the lasers, and so it means if my beam is not lying down at the photodetector, then there could be certain issues, because if it is not, we cannot fetch the signal if it is not lying at proper photodetector. So tracking and pointing techniques. So these are certain areas on which we can work upon. So next is optical communication is not only in on the land, it is also there in the space. Okay, so you can see the satellites are connected with each other. Nowadays, the satellites are connected with each other through the FSO link. So here you can see that we have used laser, and because here the distance is very large between the satellites, so there we can afford much power as compared to that on the earth. So if satellite and satellite communication is a new area in which people are working. So there is very important and upcoming area of optical communication is not only in the satellite, it is also being used for deep space optical communication. If we want to connect with the deep space, means if you want to connect with Mars, then for that communication, optical communication is playing greater role. Okay, let us discuss how it is happening. So here you can see that we are having this ground laser transmitter and we are having this ground laser receiver. So from this ground laser transmitter, we are transmitting a laser beam which is going to this satellite. This is not about Mars. This is just a communication setup which tells that how we are means using. And from this satellite, this ground laser receiver will catch the signal. So this is the way how we are connecting from ground station to the satellite. And then from these satellites, we are connected with the other satellites, right? So here you can see the NASA's future Mars telecommunication architecture. Right here you can see that this is Earth and there are some rovers which are moving around the Mars. Okay, so this is a future Mars telecommunication architecture. So you can see that there are number of options available with the connectivity. Like suppose here you can see the green line, direct to from Earth optical and RF. From this Earth to this satellite, we can either use RF or we can use an optical laser beam. So from this Earth, we will transmit the signal through the lasers, and from this satellite, it will connect with this point. The red lines are basically the wireless connections, right? So this is the first thing. The second thing is means the point which we can afford line of sight, we are transmitting that signal with the help of lasers. And if the rover is moving over the Mars, then the connectivity required in the form of wireless. So if you can see that there is some station, so we can put the connectivity through the FSO link, and from that station we can use wireless communication. So this is the way how this deep space communication takes place. So what is the planning now? That we have to launch some satellite over the Mars. So you can see that Mars can be connected with the different satellites, and then we can transmit the signal from the Earth to this satellite, and this satellite to the satellite which is near to the Mars. And from Mars, satellite number 1, it can be connected with the second with the help of this laser beam. So all these satellites are connected with the laser beams, and from these satellites we can install some fixed station which can transmit the signal through the laser light, and from that we can give this if we can afford for this wireless communication, we can launch the wireless communication for fetching the information. So optical communication, here you can see that how these are multiple lasers. So I told you that the major problem in the case of optical communication, this FSO, is that if there is some shift in the lasers. So what are the alternate to that? Now what we have done, that instead of transmitting one beam, we are transmitting 4 beams. So data can be transmitted 4 times. And similarly, instead of using one photo detector at the satellite, we are using multiple photo detectors. If there is some shift distance in the form of distance for the first photo detector, we are keeping the second photo detector very near to that, so that if first is not able to catch the signal, my second photo detector can catch my signal. So array of photo detectors can be used to solve these problems. So this is there are different type of encoding and decoding technique which can work for transmission from the Earth to Mars. So optical communication is placing a good role. So this is the latest means this is the plan that how we can connect with the different planets, but it's not yet approved. People are thinking that these type of connectivity could be work, like if you want to means communicate with Saturn, Jupiter. So means this is not approved, but people are thinking that later in the future we can use this technology for different. We can use relays. We can use satellite as a relays, and we can connect to the different planets. So this is the future of this optical communication for deep space. So if you want to do some research in this deep space communication, there are a number of problems. Deep space network, which type of network, how we can design the deep space network. Second is, if you're talking about the antenna plays an important role here. So NASA's researchers are working to design this deep space antenna. And I told you that synchronization challenges are always there in FSO. So same issues are there in deep space communication. Advances in ground transmitter, we can design some ground transmitters which should be energy efficient also, and automating operations. So this is a major area on which NASA people are working. Suppose we want to transmit the signal and there are certain plans. If plan A is not working, then go to plan B. If plan B is not working, go to plan C. So we need to do all the operations in automatic way. So if we are talking about the NASA's deep space DSN network, so people are working upon algorithms which can automate the network in a very good way. So there are some limitations on lasers. So because lasers requires a high power to transmission, so how we can provide the power to those lasers? So this is again an issue. So people are doing research that how means for the limitations on the power. The next point is planning approach to monitor and control for deep space communication, and capacity of large array receivers. I told you that for deep space communication, we prefer to have array. Nowadays, we are using large array receivers so that if there is some shift in the satellite, if there is some deviation of the first satellite, at least first or second or third, this number of arrays are there so they can fetch the information. So optical communication is, so I told you that these are some research issues on which people are working. The next area, which is very, very important, is the undersea optical communication. So see, optical communication is not only on the land or the space or the deep space, but it is also there in our lives if we are talking about the undersea optical communication. So there are certain areas in means all my submarines can be connected through the FSO, and all the equipments which are lying down on the seabed, they are connected through the optical communication. So satellites are connected with the ship with the RF. Then multiple links like optical network you can see here. They are using the optical network inside the undersea. So if we're talking about the optical network cables which we are using on the earth and which we are using on the undersea, they are totally different. Because when we are talking about the optical cables on the earth, so there is not much pressure of the water. There is not much pressure of, because they are safe. But when we have to lay down it under sea, then we just want that if some aquatic animal wants to bite it, it should not be cut. Okay, so you can see how secure these are. So there are basically 8 layers optical fiber. Apart from that, we are using some petroleum jelly, then we are using some copper or aluminum tubes, then polycarbonate is there, then aluminum water barriers are there, then stranded metal steel wires are there, so mylar tape is there. So you can see that 8 layers are there to save the optical fiber. And here you can see that how these optical fiber has been placed upon the seabed. So basically, if we are talking about the connectivity, today's connectivity, worldwide connectivity, see 99% of the connectivity which is there and which we are using is through the undersea optical cables, right? See, the basic point is how this optical fiber has been installed over the sea floor. See, there are very good organizations who are working on this way, because they are taking the optical fiber, the ship is there and they are rolling down, and then they are means there is a full-fledged network how they are installing the optical fiber over the seabed. See, optical fibers, when we have we lay down it over the seabed, so then you can see in this diagram that the person is doing person is basically watching this optical fiber, and if this shark is basically you can see that these are certain limitations, that if there is cut in the optical fiber, then the whole connectivity gets distorted. So it is not only used for communication purpose. See, we are having certain other equipments like this first equipment is used to see the earthquake value. Okay, this is for the seismology. So the companies who are doing this project, they can also use the optical fiber for the connectivity. See, when some companies installing the optical fibers over the seafloor, it's a very, very costly affair. So what they normally do, if some companies gives them an order that we require 2 optical fiber, you lay down just 2 optical fibers. So instead of laying down the 2 optical fibers, they are laying down suppose 4 optical fiber, 4 or 5 optical fiber. So 2 are using by those companies, but other 3 fibers are not used by anybody. So they are just laying on the floor, seabed, but because it's a costly affair, so the companies are basically laying down the extra fibers. So now those extra fiber which are not used for the main network are known as the dark fiber. So the companies like who are working upon this seismology, they can basically take the lease of those dark fibers. So they are basically using those fiber to transmit the information from these devices to Earth. So here you can see that and the person is repairing the optical fiber. But it's a very, very difficult task to repair the optical fiber over the sea floor. Okay. So when we are talking about the optical amplifiers, which type of optical amplifiers we are using, because we cannot put a separate unit as an amplifier. So normally we are using EDF amplifiers. So the first diagram shows you those EDF amplifiers. And this is the way how the undersea optical fiber looks like, and people are repairing those optical fiber and checking the condition of that optical fiber. So recently India, okay, I'll tell you in the next slide. So this is the India's optical fiber which has been laid down, and this is the way the how people are basically taking care of these fibers. So if we want to discuss about the India's connectivity, see, India is connected from 3 points with the world. This is the Bombay, and this is the second point, and third is at Chennai. Okay, so these are the 3 points through which India is getting connected. So when every time when we are suppose fetching the information from the Amazon, and the Amazon server is at US. So means if we are at Delhi, then we are using this FTTH, this access network, then we are going to metro network to we are going long haul network, and our signal is reaching at Bombay. Then this signal is getting is sent through these optical fibers to that server. So these optical fiber is basically the connection of the undersea optical communication, which is there all over India. Okay, and here you can see that according to the data, there is a submarine cable map.com company who's saying that Bombay is having 12, Mumbai is having 11 cable. So Mumbai is using 11 cable for connection. Chennai is having around 7 connection, and Cochin is having 2 connections. So both in Trivandrum and Tuticorin. So plus there is one news that recently in the past 2 years, the Andaman and Nicobar is also getting connected. So here you can see that this is Andaman and Nicobar. So the optical fiber was laid on here. So nowadays people, Indian government is working to provide one more optical fiber for Lakshadweep also. So this is a complete list of submarine cables landing in India. So you can see that many players like ATAL, TCL, BSNL, CFI, so they have used their optical fiber. So there are around 20 optical cables which have been laid on all over the India. And the number of fiber pair means 2 fiber pair or 4 or 6 fiber cable. These are some specifications. This data I have taken from that submarinecable.com. So if you will see the optical fiber connectivity, so this is how the optical fiber has basically how the world is connected with the optical fiber. So you can see there are a huge number of fibers. So there are a global organization who is controlling the path, that the path should be like from this to this. So you can see the major connectivity, which is nowadays we can see is all through the submarine cables. And recently, there was an article in Economics Time that the title of that article was that the wires which are running the world. So these are the optical wires which are running the world actually. So all the online, all the technology, all the connectivity are through these optical fibers. So if we want to do something in this area, then there are certain research issues like ultra long haul submarine transmission technology. We can work upon that. We can address some issues for the development of high speed network. People are working upon the different materials like the fiber different jackets, the protection schemes, amplifier issues, and if we can do something for the betterment of the repair work of the undersea optical network. Apart from this, optical communication is also playing a great role in the data center. Can you believe that in these data centers, every communication is through the optical communication? If we are talking about the different type of hard disk or the storage devices which are there at the data center, they are linked with the optical fiber cables. Even if we are talking about one hard disk or suppose one storage device, this storage device is having multiple layers, and even we can see that in one PCB of multiple layers, and those multiple layers are even connected with the optical communication. So even the interconnects which are there in those layers of one PCB, that is also through the optical communication. So all the major data center, Google data center, so they are connected with the optical communication fibers. So I told you that optical interconnects means when we want to connect the different hard disk, or you can say the layers of that PCB. So even they are connected through the optical interconnects. So nowadays we are talking about system on chip applications. Like if we earlier we were discussing that we are having pieces with separate room, RAM, and we are having certain blocks on that PCB. But nowadays we just want for system to chip application means that whole machine should be on one chip, right? And if we are talking about the system on chip application, the size is very, very compact. And all these modules over one chip are communicating with each other through the optical interconnect. So this is a recent trend on which people are working. A lot of researchers in Germany and Brazil, they are working in this area for designing the optical interconnect, because the major problem in these interconnect is like the size should be very, very small. So we have to design nanoscale type of interconnects. So if somebody wants to do research in this area, then we have to design some optical interconnect with the very small size, future peta and exascale platforms in data center and supercomputers. We can design high-speed digital system. So VCSEL is basically VCSEL lasers. So what is the need of these lasers? Like from this layer to this layer, if we want to transmit, so the lasers which has been used for communication from one layer to the other layer are basically VCSEL, vertical cavity surface emitting lasers. So these are some lasers on which people are working. People are working upon very small size, efficient photodetectors. And we can also do some work for means minimum losses in the optical interconnect, and nanoscale devices for optical interconnects. Now here is the area which we can say that in IoT, when we are talking about IoT, it's basically Internet of Things, in which we are using multiple sensors. So sensor is the first layer of the IoT, right? So you can see that optical communication plays an important role in IoT. So how it is, because the sensors which we are seeing nowadays and which the futuristic sensors are there, they all are using optical communication. Even for if we are talking about the medical diagnostics, if we are talking about the laser surgeries, if we are talking about the chemical sensing, if gas leakage, or you can see that if the means we can check the chemicals of particular material. We can even design some sensors for IoT applications, for temperature, for pressure, for strain sensing. Even we can check the environmental monitoring of, we can design some sensor for IoT application for environmental monitoring. Even for pressure sensing, we can use many sensors. We can design many sensors for body, means for health perspective, molecule sensing, force sensing, even for food safety. So number of optical companies are there, optical fiber sensor companies are there, who are developing optical sensor which are very, very reliable, right? So optical communication sensors can be designed for number of applications. Here you can see like for health, biophotonics application we are using. For environmental sensing, we are using some optical sensor. For security imaging, we are using. So optical photonics is basically diffusing into other sectors also. So this is just, I have taken one example of how the optical sensors are basically helping for the construction. I'm just giving you an overview of just one application, which is known as a construction. So here you can see that we can have number of sensors like air quality and gas level sensors are there. Then we can have optical sensors like for to check the ambient pressure, to check the wind speed. We can check the vibration. So optical sensors are there for asset and material tracking, for concrete temperature and relative humidity. So optical communication is also playing a great role for designing the sensors and for communication. So if you want to look for the challenges and opportunity in this area, then people are working for the development of various sensors like biophotonics, laser-based sensor, and we just want a very, very micro or nano structured sensors, sensor networking, environmental sensors, security sensors, defense sensors, means number of applications are there. Nowadays people are also working upon the metamaterials, which is very, very important area. In metamaterials they are basically developing the materials which can basically absorb the light. If some material can absorb the light, then the other can, then one cannot see that material. So this is another area on which people are working. So if we are talking about smart city concept, and if we are talking about the connectivity of that smart city concept, then we can say that optical communication plays a great role here. Even all houses, all the buildings, all about health sector, agricultural sector, telephone sector, metro ring network. So everything is connected through the optical fiber because we just want a huge amount of data to be transferred. So optical communication is also playing a great role to combat the COVID-19. So the ultraviolet rays and ultraviolet sterilization, they are helping the people, helping the mankind for to combat the COVID-19. So you must have seen these type of advertisement. So this is because all of the optical communication, we are able to have this high speed internet, high HD television, smart home solutions. So we can have a, okay. So next is if you want to start some research in this area. So first of all, we just want that research should be for the upcoming technologies. So we should go to the very, very renowned labs and see what projects the people are handling. Like for this area, I have written that Bell Labs is working. There are certain labs like Optical Laboratory, Networks Laboratory at KTH Royal Institute, Wireless and Optical Lab at University of Houston, Optical Network Laboratory, Carleton University, and even India is having very good architecture on the setup of optical labs. IIT Delhi, IIT Bombay, they are having very good setup of optical communication lab. We can see what type of projects they are working upon, and we can see the area also, because when we have to do some research in these areas, when we are doing some research, so choose the topic which is upcoming topic, right? Which is not implemented yet. So this is the future. Basically, we advise that you have to take some future topic so that you can see that there is a scope of research. Otherwise, if we'll take the topic which is already used, like DWDM is 20 years back, okay, so there is not much scope of improvement. So you just work and see what are the futuristic technology on which people are working. I have just given you one example, like this. They have in the KTH Royal Institute of Technology, Sweden. They are they're designing this project optical 5G transport network, and the other project is like green optical internet for the data center. So they are working on developing these type of projects. So you can see some problems on which you can work upon. Next is there are number of softwares which are there. So this is a list of software, optical software, which from which you can start working. Then suppose I'm giving you just glimpse of the first software opti system which is there at our DTU. So you can develop some systems like this is a drag and drop software. So you can develop some system like laser is there. You can change the specification of the lasers. Then pseudo random bit sequence generator is there. You can change the data speed, and this is basically non-return to zero pulse generator, and number of modulators are there. So here we have used Mach-Zehnder modulator. So this is the way how the results can be seen. Like it's a 1010, so you can see 10010. So this is the information from the oscilloscope visualizers. You can see your results in the form of spectrum analyzer. So here you can see a simple example. It's a very, very simple example of power budget in which we are transmitting the signal. And here is my signal. So we are modulating the signal with the help of lasers. And then we can see at the photodetector, we're retrieving the signal and we can check the bit error rate. So in this way, we can start doing some work. So this is another WDM system simulation. Here you can see that multiple wavelengths can be transmitted over the same fiber, and we can check the output, that we can retrieve our output in the same way, and what is the bit error rate for that. So these are some samples of, this is another scenario, means you can develop some hi-fi scenario also, like with the bidirectional optical fiber, how the system will set up. These are some circulators. This is a very intense library. You can use some fiber loops also, splitters also. There are certain number of component, optical network units are there. So if you start doing some research in this area, so this is basically, you can start with some software. So thank you. So are there any questions, please? Hello.
Any questions?
If there is any question, you can ask participants.
No questions, ma'am.
It was really nice, Gurjit. You did
Thank you.
covered a lot of things.
Thank you, ma'am.
Now I would like to thank Gurjit ma'am for this informative lecture. Ma'am has covered various important topics in her lecture, like packaging of fibers, research opportunities in optical fiber, capacity of optical fiber, top global optical fiber manufacturing companies, scope of optical fiber in India, role of optical fiber in 5G, use of optical fiber in underwater communication as well as in deep space communication. So all the topics are very informative and in the research perspective and also learning perspective. Thank you so much, ma'am, for
Thank
this
you,
lecture.
Thank you. Thank you, everyone. Okay. Ma'am, the test timing is at 3:30. So,
Ma'am, can we start test little bit earlier from 3:15?
actually, we
3:15 if everybody, but we have announced it in as
Yes, ma'am.
3:30.
Yes, ma'am.
Somebody
it's
joined late.
3:30, ma'am.
Okay, ma'am. Then we will start at 3:30.
We have
3:30.
announced it now, so if people join later, then it will be difficult.
Yeah.
Yes,
This may be the
ma'am.
case.
Right.
Okay, so we will start at
Actually, could
3:30.
you please stop the recording?
Yes, ma'am. Yes, ma'am. Yes.